Hello, this lesson is titled How Do You Draw and Write Electronic Configurations? For those of you that I've taught over the years, you'll have heard me say, don't worry about electronic configurations. It's a really fancy word for basically saying putting electrons in shells, and that's what we're going to do in this video. Just a couple of slides just to kind of give you a bit of background. We should be happy with what you can see here. The fact that the first shell in all atoms holds 2 electrons, second shell 8, third shell 8 electrons. Okay, so the first 3 shells can only hold a maximum number. Once you get past the third shell, 4th, 5th, 6th and so on, they can hold a varying number, and particularly at GCSE level, you do not need to worry about how many electrons can be in the third shell, in the 4th shell and beyond. At A level you do, and as you know, if there are any A level students listening, the way we do configurations is slightly different, but at a GCSE level we put electrons in shells for the first 20 elements at GCSE. That's what you're expected to know, which is it's good that we know a number because it means that you can practice all 20, but also it kind of reassures you that you don't need to know the maximum number of electrons for all the other shells. So 2 in the first shell, 8 in the third and the second shell. Now, before you start this video, if you're doing it with me while we go along, you need a copy of your periodic table in front of you. This can be your own one, it can be on the internet, back of textbooks. GCSE textbooks tend to have a periodic table in front of them. That's the one I've got in front of me. The reason being is you're going to look at the rules here, and the rules will refer to the periodic table. These are the steps that I use to write and draw electronic structures. Okay, so notice here I've said number 1, work out how many shells it has. You look at the period number, that is the row that it is in. It then says draw the right number of shells and place the element symbol in the middle. Look at the atomic number. Again, you get this from the periodic table. The atomic proton number is the bottom number at the bottom of each of the elements in the periodic table. It then says fill the shells, start with the last shell. Electrons in this shell is dependent on group number. Again, that's something you get from your periodic table, which is why it's really important that you have it in front of you. Now, there are lots of different ways you can do electronic structures. I personally start with the outer shell and work my way in, but and I'll show you both ways. You can also start at the inner shell and work your way out. Okay, so let's look at some examples then. Let's start with hydrogen. Hydrogen is in row 1, period 1 of the periodic table. So therefore, it only has 1 shell. And I said you put your element symbol in the middle. Now look at its atomic proton number. Its atomic proton number is 1. It means that there's 1 proton in the nucleus, but we should be happy with the fact that the number of protons and electrons is equal. So if there is 1 proton, there is also 1 electron, represented here by 1 E minus. Okay, now we need to fill the shell with the electron. Now this one is nice and simple because there is 1 shell and only 1 electron. So we represent electrons by a cross. You can represent them as dots, and that comes up a little bit later on. For now, just represent them as crosses. Let's do magnesium. Magnesium has the symbol Mg, and it is in the 3rd row or 3rd period of the periodic table. So there is going to be 3 shells. Okay, now the bottom number of magnesium is 12. 12 protons, 12 electrons. Now, I did say to you on the previous slide, start with the fill the shells and start with the outer shell. Now, the reason being, the reason I do that will now become clearer. Magnesium is in group 2, so it means there are 2 electrons on the outer shell. Now you work your way inwards based on the fact that you know how many the inner shells can hold. Now, the second shell holds a maximum of 8. So we've got 10 more electrons here to place because I had 12 in the beginning. I added 2 on the third shell. I've just put 8 in the second. I couldn't have put all 10 here. That would have been incorrect because that shell can only hold 8. Now the first shell can only hold 2. So therefore I have now put 12 electrons into the shells. 2 in the first, 8 in the second, 2 in the outer. Okay, I'm now going to do fluorine. Fluorine has the symbol of F. It is in the second row or second period of the periodic table, so it has 2 shells. Its proton number is 9, so it therefore has 9 electrons, and we fill the shells. Now fluorine is in group 7, so its outer shell will contain 7 electrons. 1, 2, 3, 4, 5, 6, 7. It means that if we have 9 electrons to place in the shells and we put 7 on the outside, 2 must go in the first shell. As you know, the first shell can only hold 2. Now let's do potassium, one of the bigger atoms that you have to do. Potassium has the symbol K, and potassium is in the 4th period, 4th row, so there are 4 shells. Okay, the bottom number of potassium, the proton number is 19, so it has 19 electrons. Now again, I can fill this one from the outside in or from the inside out. Now you can start from the outside in on this one. Potassium is in group 1. Now you don't know how many electrons are in the outer shell, and you can see that's irrelevant. We can still do the example. If potassium is in group 1, it has 1 in the outer shell. So out of my 19 electrons, I've placed 1. I've got 18 more to place. And remember, I can't place all 18 of those in the third shell because the third shell can only hold 8. So I can only put 8 in that shell. Okay? My next shell down, shell 2, can also only hold 8. Okay, so if you total up where we are right now and how many we've added, we had 19 to begin with. We put 1 in the outer shell, 18. We then put 8 in the third shell. We had 10. We've just put another 8, which means that we would have had 2 electrons remaining. They go in your first shell. Now, those 4 examples there are drawing the electronic configurations. You can also be expected to write them, and writing them is really simple. I'm going to start from the bottom upwards. What you do is you list how many electrons are in the shells and you separate out the numbers by a full stop, like so. So in potassium, we have 2 in the first shell, 8 in the second, 8 in the third, 1 in the outer. Fluorine, 2 in the first shell, 7 in the second. Magnesium, we've got 2 in the first shell, 8 in the second, and 2 in the third. For hydrogen, we only have 1. Some more examples. Lithium. Lithium is in row 2 of the periodic table, or period 2. It's got 2 shells. It has an atomic proton number of 3, so it's got 3 electrons. I'll fill it from the outside, from the inside out on all of these. The first shell can only hold 2, so I cannot put all 3 in my first shell because my first shell can only hold 2, 1 in the outer. I would write that as 2.1. Calcium, quite a big one here. Hopefully I've got enough room because it is in the 4th period. So there are 4 shells. Now, in terms of filling these shells, we need to look at the number of electrons. The proton number is 20, so there are 20 electrons as well. We're going to fill the shells going from inside out. First shell is 2. The second and the third shells can hold 8. And then the final shell, 2. 2.8.8.2. Now for argon. Argon is in the 3rd period, 3rd row, so it has 3 shells. The symbol is AR. are 1, 2, 3. Argon has 18 electrons. Okay, so therefore we're going to fill the shells. We have 2 in the first shell, 8 in the second, 2 plus 8 is 10, 8 remaining in the outer. And it's the first atom that we've looked at that has a full outer shell, 2, 8, 8. And finally for sulfur, sulfur is in the third period as well. So it has 3 shells, okay? In terms of electrons, it has 16 electrons. So you can see how I've just here randomly picked elements that are quite close to each other in the periodic table. Sulfur, 2 in the first shell, 8 in the second, 2 plus 8 is 10, 16 electrons, so 6 in the outer, like so. Okay, 2.8.6. What I would now do is go back to your periodic table, go and pick, let's say, 5 or 6 random elements in the periodic table that are below the element calcium, because remember I said at the very beginning of the video you only need to do the first 20 elements. You can't be expected to ask anything else about that from an electronic configuration perspective. So go and pick 5 random elements, give it a go, and don't forget you're always welcome to come and see me, drop me an email, and I will mark your answers for you.